Welcome to the Geometry Final Review. This is Standard 11 Part 1. We're just going to talk about some ideas to kind of give you an overview of what this standard covers, and then in the other set, and some formulas. And then we're going to actually probably do some problems in the other parts of this standard, the other part videos. Okay, so let's start by thinking about what prism, cylinders, cones, and pyramids are. Cylinders are pretty easy. Most of us have a good idea what a cylinder is. A cylinder basically is round. It has a circle on each end. And the way I like to think of these is my children had a little toy that used Play-Doh, and they'd put their Play-Doh in, and then it would shoot out, and as it shot out, it would come out in this shape, and then they'd cut it off, and they'd have a shape that has two ends that are the same. Like this has a circle on one end and a circle on the other that are exactly the same, and then it's pretty much uniform throughout. Same thing with this one. And these are cylinders, okay? Prisms, this is the prism you're probably most used to. It's a rectangular prism. And or this one might be a square. If you're looking at it from this way, it's a square. If you're looking at it this way, squares and rectangles are kind of that way. And once again, if it went through a machine, it would come out like this, and then it has two ends that are the same. And prisms are kind of like that. Here's another one. This is a hexagon prism. It has 6 sides, and it two ends that are the same. We have a couple of other prisms here just to kind of look at real quick. We have this is a triangular prism. And this is an octagon. 1, 2, 3, 4. Yeah, this is an octagonal prism. Has an 8-sided octagon, regular octagon on both ends. And okay. And these are kind of cubes. Cube is a kind of a rectangular or square prism. Okay. Now we have also pyramids and cones. Pyramids and cones usually are kind of pointy. And cone will usually have a circle on one end, and a pyramid usually has either this one happens to have a triangle, not a triangle, a square on the bottom, but some pyramids, like this one I've drawn here, have a triangle on the bottom also. And then our last group, we have, this looks like 2 spheres, but if we look closely, see if we can show it. Maybe that's the best way to show it. This is actually half. So this is called a sphere, and this is called a hemisphere or half a sphere. And basically the formulas for it tend to be half of whatever the sphere is. Okay, so now let's see if we can go on and maybe do something productive here. Okay. Here is... Okay, so we wanted to talk about surface area first. Surface area is the amount of space along the outside. For example, if I wanted to find the area of this side, it's a rectangle, so I'd find the length times the width, and that would give me the surface area just on this side. But this shape has 4 sides and 2 bases. And so to find the surface area, we talked about making a net. You can make a net. A net of this might look something like this. It'd have 2 square ends, and then it would have 4 rectangles. And so if I find the area of all of those and add them together, then I get the surface area of a 3-dimensional object. This one has a similar kind of similar kind of surface area. It would have the area of 2 hexagons and the area of 6 rectangular sides. A cylinder is kind of interesting. A cylinder's surface area is going to be 2 circles, so pi r squared is the circle formula, and then it's going to be the area of this outside. You may not think about it, but if this were a can and I cut it straight down like this, and then could unfold it, what you would get is a net that looks like 2 circles maybe, And then attached to those two circles, there would be a rectangle. Now the interesting thing about this rectangle is its height we're going to know, but its width, its distance around, is going to be the same as the circumference of the circle. If you think about taking this metal and wrapping it around each of these two ends, so wrapping it around, you're going to see that that wrap around is going to be the same as the circumference of that shape. Okay, so let's go through some formulas. We've got about 4 minutes left, so let's see if we can cover some formulas. Okay, so we talked about that. Oh, they're not there. So here's some formulas. So, the other way you can find surface area is if you have a formula. We don't have one for most of the shapes, or we haven't developed them for most of our shapes. We could give them to you, but you'd have to memorize them, and you'd probably forget. Okay, so I don't want to start with cones. Here we go. Here's the ones I like. Volumes of prisms or cylinders. In a prism or cylinder, we're going to talk about a new way of doing it. We're going to find the area of the base and multiply it times the height. You've done this all along. If you had a rectangular prism like this, you did length times width times height. But what you were really doing is length times width is the area of that rectangle on the bottom, then multiplying it times height. Let's extend that. Let's find the area of the circle at the bottom, that'd be pi r squared, and multiply it times the height of the cylinder. Let's find the area of the triangle at the bottom, that's 1/2 the base times the height of the base here, and then you multiply it times the height of the prism. So we get a couple of different formulas for finding the volume of prisms and cylinders. When we get to cones and pyramids, we talked in class about how a cone or a pyramid isn't quite the amount of volume as the associated cylinder or prism. You could have a cylinder going straight up here and then going across the top there, and you'd have to cut some of it off to get this cone. And what we find out, and you'll later learn some things in calculus about this, is that it basically ends up being 1/3 of the area of the same, or 1/3 of the volume of the same cylinder. So what we do is we do 1/3 the area of the base. In this case it's a circle, so pi r squared. In this case it's a triangle, so 1/2 base times height. And here it's a square, so we would do, or a rectangle, so we would do length times width, or side times side. Okay, the height in all of these in a cone is a little bit different. It actually goes straight down inside the middle, and then so it goes to a point in the center and it goes up at a right angle. Let me see if I can find my cone here. It's kind of bright, so I'm not sure you'll see this. It's not going along the edge. It's not going along this edge. It's actually going, the height would go right through the middle to the tip. Okay, same thing with the cone. There's a height along the side. We use a word called slant height, which talks about the height up this side of the pyramid. But the height for the formula we use goes right up the middle. So it'd be kind of like if you could see into the pyramid, like here, it would go from the vertex at the top, and it would go down the middle to the middle of the shape, and then usually we draw it like that, kind of going to one of the sides. Okay, I don't know if you can see that, but anyway, 1/3 the area of the base times the height. We've got 1 more minute, so here's the last set of formulas. The surface area and volume of a sphere. Probably won't use this one, but it's good to know. The volume is 4/3 pi times the radius squared, and I've drawn where the radius from the center of the shape out. And the surface area is 4 pi r squared. And if you want to find the, for a hemisphere, it's pretty much half of these is the way you go. Okay, so that's this one. We'll go on to some problems in the next part.